Hello everyone, welcome back to Grade 10 Applied Math here with Mr. Stone. So this is the lesson for Unit 2, Activity 2, and we're going to start introducing now what we call quadratic relationships. You've seen these already a little bit when we looked at differences, when the second difference of a table of values ends up being the same. Not the first difference. When you look at the first differences and then you look at the difference of the differences, second differences, if those are the same, we end up with something called a quadratic. And quadratics are really interesting in terms of their shape and some of their features, and also in how to use them for modeling things. Like if something's dropped, something falls with gravity, um, its position, where it is in space, um, follows a quadratic. Okay? And if we graph these, we get a cool shape, which is no longer just a boring old line, but is a parabola. It's this curve. It's a very special curve called a parabola. You may have heard this in terms of like a parabolic reflector, or something is parabolic or something like that. This is just a very mathematically precise shape, which is what a quadratic relationship makes when you graph it. It looks like this curve. And what's interesting about this is that it's symmetrical. There's like a mirror here. These two sides are the same. It has like a lowest point. Instead of going forever, like with a linear relationship, it goes forever down, forever up, forever over, forever over. In this case, it has this sort of floor. It has to have values greater than that, right? It'll go up forever, but there's a minimum value, right? So let's introduce some of these terms that we can use to describe this. So in terms of the features that a parabola has, the first one I want to look at is that turnaround point, that bottom. And it has a mathematical term called the vertex, basically the bottom of your parabola. And we can give an x and y value of that. In this case, it's over 2 and down 1. This has a coordinate of 2, -1. That's the lowest point of our parabola, and it's also the mirror. So then we can say what that mirror is. It has a funny name. Instead of saying it's the mirror, it's the axis of symmetry. Okay? It's where the symmetry is. It's this line that we produce here, so that the right-hand side and left-hand side are the same. And notice it goes right through the vertex. So all we have to do is you write down that x equals 2, right? A vertical line has an equation x equal to, it has all the same x values of 2. All you have to do is you take your vertex and you take the x value out of the vertex, and you write x equal to 2. Okay, so you just done. Take your x value of your vertex, and you got your axis of symmetry. We can also state the minimum value, and in this case, that's the y value of my vertex. So basically, if you know your vertex, you know both of those already. You just take them apart. 2, -1 splits up into the axis of symmetry is x equals 2, and the minimum value is y equals -1. Right? You can sum it all up right here. But mathematicians like to have different terms for different things. Okay. Another thing we can describe is the y-intercept. Where does the line hit the y-axis? Remember, it's the y-axis up here, it's the x-axis down here. Ugly. Okay. So in this case, the y-intercept is 0, 3. It hits the red line hits the y-axis at the point x0, and the y value is 3. And the other one is we can look at the x-intercepts. Now, but this is a little bit tricky because there's actually 3 different terms for the same thing. Right? We can say it's x-intercepts. That makes sense, right? It hits the x-axis at 1 and 3, or 3, 0, and 1, 0, and 3, 0. But it's also called zeros or roots. Okay, sorry about that. Maybe we'll talk about why in a later lesson, but for now on, just know that the x-intercepts are also called roots or also called zeros. So if ever a question asks for zeros or roots or x-intercepts, it means all the same thing. So in this case, it's 1 and 3, or 1, 0, and 3, 0. Okay, so those are all the important features of a parabola. So what you're going to have to be able to do is take a parabola, this one. If I give you this parabola, you're going to have to be able to extract all that information. So let's start out here. So vertex, that's pretty straightforward. Where's the bottom? So I look on my x-axis, that's -1 and -9. Okay, so my vertex, I went over 1 and I went down 9. Left 1, down 9 to get to my vertex. Right? So now that I have my vertex, I can right away get my axis symmetry and maximum value. Or in this, maximum value. In this case, no, this is a minimum. Ooh, 1 second. Pardon me, 1 second. Sorry about that. I have to fix that. So the minimum value now is going to be -9, and the maximum value. So the the axis of symmetry is going to be -1. Right? We take our x value, and we take our y value, and we're done. Okay. What are my zeros? So my zeros are 2. Right? It hits the x-axis at 2, 0, or -4, 0. And the y-intercept is 0, -8. Okay, so we just looked on here. Remember, zeros are the same thing as x-intercepts. And those are my zeros here. And my x-intercept is there. And my vertex is the bottom. Okay, that's pretty straightforward once we have an example like that. Okay, so you get your vertex. From the vertex, you can get your axis symmetry and your minimum or maximum. And then you can look at where it hits the x-axis to get your zeros, and then where it hits the y-axis to get your y-intercept. Let's try one more. So vertex, okay, that's here, right? That's my vertex. So that's over. Remember, I'll always write x first, y. So always go over first, and then up and down. So I go over -2, up 1. That's my vertex. Then I can take my x value of my vertex, put it into here. So that's my axis of symmetry. X equals -2. X equals -2. And the maximum value in this case is going to be 1, because the y is equal to 1. This point is -2, 1. Zeros are -1, 0, and -3. That's my zeros, where I'm hitting my x-axis. And my y-intercept is where I hit my y-axis, which is going to be 0, -3. And we're done. That's it. Okay, so basically all this is looking at a graph, finding points on it, and writing them in the right spot. Okay? All right. So I think you guys should be okay with that. Any questions, feel free to ask. Now let's do it backwards. Okay, we're given the numbers. We're given this side here, and we're asked to make the graph. Okay, so graph the parabola given the following information. Has a vertex of -3, -4. Okay, so let's remember this is the x-axis, this is the y-axis. X comes first, goes y. So I'm going to go to the left 3 and down 4. Okay, so that's my vertex. Vertex is -3, -4. Right, so taking care of that one, good. My zeros are -5 and -1. That means zeros, remember, is x-intercept, so it's going to hit the x-axis at -5 and -1. And then there's a y-intercept of 5. That's going to be up there, right? The y-axis, it's hitting the y-axis at 5 and hitting the x-axis at -5 and -1. So we have our 4 points. Now all we have to do is connect our dots. Now, when you're doing this, just be careful that you're doing it symmetric on both sides. I don't care too much. I'm not going to be a stickler with exactly how well you, at this point, we're going to see another way that you can graph things a little bit better. But the only really important thing when you're drawing parabolas is don't make them pointy at the base. Okay, parabolas are not V's. Okay, they're like U's. They have a round bottom. Okay, so let me try that again. Okay, doing this on a computer screen is not as easy. Oh, almost hit it. Almost hit it. Let's try that again. That's it. All right, that's as good as I can do. Hopefully you guys can do better than that. Just put little arrows on the end as well. and we're finished. Okay, so that's how we graph a parabola given the information. Okay, now that's all I want to talk about for parabolas, but there is something that I noticed I missed in the other lessons. Okay, and that's how do you go from a table of values and get slope instead of from a graph. From graph we can do rise over run, but I never actually talked about how to do it from a slope. Sorry, from a table of values. How do you get slope and y-intercept from a table of values? Now we have to do this looking at differences. So notice on this side, on the x values, everything is going up by 1 every time. Okay? So in this case, we can think about this as my run of my graph. Right? And here I can say, that's not how you spell rise, Mr. Stone. Okay? Now I can look at my differences, and that'll give me my rise, because that's how much I'm changing in the y-axis. I'm going up by 2 each time. Okay? So again, rise over run. Oh, my mistake. I'm going from 5 to 2, 3 to 1, 1 to -1. So that means I'm losing 2 each time. I was going too fast. Apologize. So my rise is 2, or -2, sorry. I'm going down by 2 each time. I'm running 1 each time. So my slope is -2. Okay, so I'm taking care of the slope. Yeah, rise over run. Now to get my y-intercept, remember my y-intercept is where does my line hit the y-axis. And notice that this value, whatever this value is, it has an x-coordinate of 0 all the time. Right? It has some y value. Let's call it y for now. So the x-coordinate is always 0. So let's look at our table. Where is the x equal to 0? X is equal to 0 right here. So right away, it tells me the y-intercept is 1. All we have to do is look on your table, find out where the x value is equal to 0, and that gives you your y-intercept right away. All right? Or doing it backwards, what happens if it tells us the y-intercept is 3 and the slope is 2? So again, y-intercept of 3. So that means it has to have an x value of 0 and a y value of 3. Okay, so we know 1 point right away. It's telling us that on my graph, it goes through the y-axis at a value of 3. The x value is equal to 0 there. And it tells me that it's going a slope of 2. Slope of 2. And what's the rise over run of a number 2? It's not a fraction. Now we can make it a fraction by putting it underneath a 1. Anytime we have a slope given to us just as a single number, put it underneath a 1. So now we have our rise of 2, a run of 1. So I'm running 1, rising 2. Or, right, I'm going up 2, which will bring us to 5. Running 1. Running another 1, up 2 to 7. In the opposite way, I'm going down in the x by 1. That means I have to go down in the y by 2. Okay? Or if I just write it out nicely, again, we have a y-intercept of 3. So that's right here. Oh, sorry, y-intercept of 3. That's here. And we're going up by 2 each time. All right? Okay. So that's everything I want to talk about today. So again, go back here. So remember quadratics. We have all these, here we go, all these terms. And looking at slope from a table. All right. So is there anything else? No. Okay. So I'll be talking to you later then. Take care, guys.